Hey everyone, thanks for listening to another episode of DIB Innovators. Today I'm speaking with Mark Valentine, or as I call him, Drifter, Global Head of National Security Strategy at Skydio. Drifter, thanks for chatting with me today.
Hey, Otto, it's great to see you, man. Glad to be here.
Yeah, welcome to the podcast. I've been trying to set this up for a while, so I'm super excited. Your perspective on both your journey to get to this place as well as what you're seeing in, the hot button topic of drones is going to be super interesting. So really appreciate it. I think what's interesting, if we take a step back is, you and I both flew jets, fighter jets in the Air Force together. It was awesome, but not many make this transition kind of as you have into a commercial sector. Talk to me about kind of your journey and what enabled you to get to where you are right now.
Yeah, that's a great question, Dave. Really, it started for me before I even entered the military. So I grew up, I was always pretty good at math and science. And, I got one of the very first personal computers you could get. It was a Commodore VIC-20, man. Thing had like 3 kilobytes of RAM. And
Was that before the Commodore 64 or after?
It was. So,
Dang, that was early.
yeah, the Commodore VIC-20 was like the precursor to the 64. So I moved up the stack later and did get a Commodore 64. But anyway, this was all during middle school, high school. And so I kind of nerded out on that stuff. I enjoyed kind of teaching myself how to program. I thought logically like that. And then at the Air Force Academy, I studied astronautical engineering, which had a pretty big computer science and double E component to it. And I really, really enjoyed that stuff. I realized, okay, I don't necessarily want to be an astronaut, and I fell in love with tactical flying. So when I graduated, I went into the flying world and flew fighters like you did. But because of that, I'll call it kind of tech nerd background that I had, I kind of gravitated to what I call the nerdier aspects of being a fighter pilot. So I got really deep into electronic warfare. So I was a Block 50 pilot. So we had the high-speed anti-radiation missile, and we had a sensor that like 2 people on the planet could figure out how to program. And that thing just made sense to me. So I got really deep into that. Through that, got into a lot of other sensors that we would put on the F-16, whether they were new targeting pods, IO, ER, night vision goggles, all sorts of things like that. It just really, really excited me. And then I had a really, really cool opportunity. I had already done war college, but I got selected for a program called the Secretary of Defense Fellows Program. So this was a program that Secretary Perry started right after the Gulf War, where our forces did an amazing job on the battlefield. And in his mind, he's like, man, we are really good at fighting wars. We were really crappy at everything in between those wars. And so he created the SecDef Fellows Program to send promising military officers out in the industry. So for a year, with the goal of bringing innovation lessons back to the Pentagon. So there were 10 or 12 of us that year, a couple Army, a couple Navy, a couple Air Force. And we went and spent time at the UVA School of Business, the Darden School, which was phenomenal. And then they farmed us out to multiple Fortune 500 companies. So I spent a year at Microsoft while I'm still in uniform. And that was a transformational experience for me. Because prior to that, I had done nothing but wear my uniform and serve in the military in a public sector capability, which was awesome. I learned a lot. But that opportunity to spend a year at Microsoft, which it was an interesting time as well, because that was right when the big hyperscalers were starting to operationalize what you and I now refer to as cloud computing. And I got to work with a small group of super, super smart folks that were cogitating on the problem of, hey, in a world where the marginal cost of networking, storage, and compute is driven almost to zero, i.e. a cloud computing world, what does that mean for humanity? What can we do after that we couldn't do before? And as it turns out, that enabled things that we're seeing a lot of now, machine learning, artificial intelligence, et cetera. And that was it blew my mind. So when the fellowship was over, I went back to the Pentagon, did a joint staff tour, did another command tour. And then I elected to retire in 2015. And, a lot of people with our backgrounds will decide to, maybe go to the airlines or you go to a large defense contractor. And those are phenomenal career paths. But I just kept thinking back to that time that I spent at Microsoft and thinking about AI and ML and what it could enable. And I just ultimately came to the conclusion that, what? I think those things are going to have a bigger impact on how wars are fought and won in the future, maybe more than the next airplane or the next missile or the next ship. So I jumped in with both feet, and it was an awesome transition.
And where'd you go?
So I initially worked at Microsoft. I worked there for about almost 6 years. And I started out on our Air Force team and then moved up the chain there and probably got promoted faster than I should have. Within a couple of years, I was the general manager of our entire national security business in Microsoft, which basically dealt with all the stuff Microsoft did with the US Department of Defense and the intelligence community. And so I got really phenomenal experience there, broad swath of technology for broad swath of users. And then later on, I met Alex Wang. We were both working on Project Maven, me from Microsoft and him from a small startup that I really didn't know much about called Scale AI. And he and I started talking, and that turned into a job offer, which was a phenomenal opportunity to build a team almost from the ground up, focusing on our entire federal government to include federal law enforcement, as well as the national security community. And so that was a pure play AI company, recently mostly acquired by Meta. And then Alex is now working for Zuck. So a phenomenal experience there. And, what I really got to do there that was different was I got the opportunity to not only work on the backside of things where you're selling things and supporting them, but also where you're starting to build them from scratch. So I had an engineering team that I got to work with, and again, some amazing things. And from there, I'm like, you know what? I think I'm going to retire. So I did that for roughly 3 years. We built a phenomenal business that was doing great stuff. We had just finished a 3-year plan for the next 3 years of growth. And I'm like, you know what? I think I'm good. I'm going to retire. So I did. And I lasted about 4 months. Yeah, my wife tells me I'm not good at retiring. But anyway, then I met Adam Bry, who's the founder of Skydio. He and I started to talk, and it was just a really, really interesting problem set where you have this intersection of stuff, right? You had aviation on one side and AI on the other. And it was the intersection of those things and really bringing AI out of the second dimension into the third dimension with robotics, and just a phenomenal opportunity. So I joined Skydio and was the president of what we called our global government business, which was essentially the US federal government and national level governments around the world. And I've been doing that now for about 3 years. And recently, I've kind of given over the day-to-day operation of that. And I'm focusing on a few more strategic projects. And that's why I'm taking on a new role to lead our national security team.
Awesome. Now, what a background. Did you meet Bill Gates? We talked about these other founders.
I met him real briefly when I was a fellow at Microsoft. So that was roughly 2009, 2010. So he was transitioning out. Steve Ballmer was there as the CEO. Bill Gates was still the chairman, but like I said, was starting to transition out. And then when I became a full-time employee at Microsoft later, Steve Ballmer was gone and Satya Nadella came in. And I tell you what a phenomenal leader Satya was. When I think about like leadership and business acumen and the way I try to practice those things, I've taken so many lessons from Satya Nadella.
That's great. What's the difference between, in kind of in a leadership role and something like Microsoft, behemoth for these startups? How would you weigh those two? Pros, cons, differences?
I think at a macro level, it's all the same. Some of the same skill sets are important. And again, one of the biggest skill sets that I learned, and this was really from Satya's Microsoft, that, if I had one thing I could go back to my younger military self and say, learn this lesson earlier, it would have been this idea of a growth mindset. So I think that is the number one thing anyone needs, big company, small company, doesn't matter. But this idea of a growth mindset is supremely important. Part of that is, first off, recognizing that, something called an internal locus of control, that the world is not just happening around you, that you actually can affect what happens around you. That's number one. And then number two, there are lots of different definitions about what a growth mindset is. The operational definition that I use is one that Satya used to say all the time. And that is, hey, I don't need a company full of know-it-alls. We have plenty of smart people here. I don't need a company full of know-it-alls. I need a company full of learn-it-alls. People that are confident enough to admit what they don't know. They're confident enough to ask questions, even in front of their subordinates, which then gives them license to do that same thing. And from that confidence of admitting what you don't know, admitting that there are things that you can learn, and that gets to that continuous improvement. And quite frankly, isn't completely unsimilar to what we did as fighter pilots, but we limited it to that narrow subset of tactical aviation, where we would go out, plan a mission, we would execute, the mission, then we would come back and debrief. And that debrief actually was the longest part of the mission. And, as well as I do, that in the Air Force fire community, we have this idea that, hey, there is no rank in the debrief. And that was true for the most part. And the idea behind that was, hey, if a general does something wrong, you tell them they did it wrong, they should learn from it. If a lieutenant does something wrong, you tell them they did it wrong and they should fix it. And then taking those lessons learned from the debrief and incorporating that back into the next mission planning. So that part of it, I think, is similar. But like I said, in the part that I learned from Satya is there's a broad swath of activity. It's okay. And you need to implement and demonstrate that growth mindset across the domain. So I think that was probably the biggest thing I've learned from my activities in business.
Perfect. I'm sure in the smaller companies that really paid dividends.
Yeah. And I'm sorry, I didn't answer your question. I asked my words out. So, the differences though, in like the big company, again, some of the same skill sets you need, a little more coalition building, because, much like DoD, which is the world's largest bureaucracy, you've got different pockets of competence. And ultimately, your goal is to stitch together those pockets of competence to make a holistic solution or, accomplish a mission. So I think there's a little bit more diplomacy, a little bit more coalition building that you have to do sometimes in the big companies. Also takes a little more patience because it definitely takes longer, even though still in the private sector, it happens a hell of a lot faster than we were used to in the five-sided building. On the smaller company side, though, again, same basic skill sets. I think the biggest thing is like sometimes you're on your own and you just got to make a call. You don't have a whole lot of backup. No one's checking your SIGs and going, hey, have you thought about this? Have you thought about that? So it takes a little bit of guts sometimes. You know what? With no additional guidance, I'm going to do this. And, Alex Lang used to talk about, making quick decisions. And he would talk about kind of dividing decisions into one or two categories. Is it a two-way door or is it a one-way door? If it's two-way door, meaning, hey, you can make this decision and without a whole lot of cost, complexity, time, or money, you could reverse it. Now you should be more spring-loaded to make that decision to move fast in those environments. In contrast to the one door or the one-way door decision where once you make it, without a whole lot of time, money, and other things, it's going to be really hard to reverse it. Those you need to spend time on. But recognizing the difference between those two, I think is important. And like I said, in the smaller company, oftentimes you're wearing multiple hats. You're doing some finance, you're doing some HR, you're doing some product planning, you're doing some engineering, you're doing some selling, and you're doing some supporting all on the same day. So that broad swath of talent is important. But like I said, I think it comes down to you got to chuck a rock sometimes, and you don't have a lot of backup oftentimes in the smaller companies. So is it a one-way door, two-way door? If it's two-way, make the decision, move out and go, and figure out what went wrong and fix it later.
Yeah, I think that's a great perspective. The other thing I see too is big companies, bureaucracies, there's like a shell framework of what you work within. That's like, especially in the government, I imagine at Microsoft.
Yeah. Well, another thing I learned, like in a big company, like when you're working with people, and this really was hard for me to learn to begin with, because you and I both came from a culture in DoD where literally our pay statements or our pay scales were posted on the internet, right? So everyone knew exactly what everyone made. And the only, differential between people was, what badge they were wearing. Whereas in a big company like Microsoft, someone told me this early on. It took me about a year and a half to where I figured out that it was true. And that was like figuring out what pay plan people were on and what their incentives were. And actually sometimes asking them, were they on an engineering pay plan, a sales pay plan, well, whatever, and then what their metrics were based on, because you could often very quickly decide, all right, is this person even interested in what I'm trying to talk about here? Yes or no. And that was a shortcut way to build some rapid coalitions.
That's perfect. It is funny how incentives drive behavior, but it's
go figure.
Great. So with listeners that are unfamiliar with a Skydio, a drone company, we got that. Just describe the mission and, technology, what sets it apart, and focus a little bit more on, I'd say, national or federal security applications.
Yeah. So at the highest level, Skydio is the result of the genius of a guy named Adam Bry. So he's our founder. And I think the founding story is important to answer your question about what it is that we do. So Adam was a world champion remote control airplane pilot. So you think about those subscale airplanes that have the motor in them, and you have a controller, and you literally are hand flying these remote control airplanes. Well, he was a world champion at it, and his basic thesis was these things could really change the world if more people use these mobile area sensors, but they don't. Why don't they? And his insight basically was they don't do it because they're really hard to fly and they're really easy to crash. So later on, he was a student at MIT studying AI, specifically computer vision and machine learning. And his insight was, I think if I can make an aerial sensor that is easy to fly and hard to crash, more people will use them because there are tons of use cases where people haven't even considered using an aerial asset because they're either too expensive or it takes too much subject matter expertise to fly the thing. So his mindset was make it easy to fly, make it hard to crash, more people will use it. And it turns out that was true. So the real innovation that he created, and you have probably seen a video of his master's thesis, it was taken in a parking garage, and there was a little winged glider with a little engine on it, and incorporating some computer vision models, it was zipping through the parking garage, avoiding the cars and the stanchions and everything. And it's all over YouTube. So that was his master's thesis. He was then brought to Google Wayne to start that. And then later on, put his own shingle out and created a company called Skydio in 2014. And the real innovation that he brought was this idea of creating an obstacle avoidance bubble around the drone. And he did that using computer vision algorithms and really cheap cameras. So basically, think 3 fisheye cameras on top of the drone, 3 on the bottom of the drone, then using 8 layers of neural networks to create a computer vision model, it could avoid things. So in other words, you could try to fly a Skydio drone into the tree, it will not hit the tree. It will, however, recognize that you're trying to go on the other side of the tree, and the drone will find a path either over the tree, beneath the boughs, around the tree, or if it can, navigate through the branches to get to the other side of the tree. And so that's why that baseline capability created a level of intelligence in the drone so that we actually at Skydio don't call them drones. We call them intelligent flying robots, which is actually a better representation of what they do. And then from there, that was the original Skydio drone. Turns out the same engineering expertise that it took to make computer vision models for obstacle avoidance could then make computer vision models to do other things, to classify, identify a subject, to track a subject. And this led to a whole host of autonomous features that we were able to layer into the drones up into including today, where we have true multi-agent capabilities where the drones can reason together a course of action to meet your intent, remote operations where a single human can supervise tens, 20s, hundreds of intelligent flying robots all at the same time. So again, that first capability in the AI space has then enabled all these associated capabilities that have come afterwards. So at a high level, that's what we do at Skydio, and it manifests in the real world really in 3 primary markets. So one of them is a commercial enterprise market where we have customers that range from electrical suppliers to architecture and engineering firms. And what we see from them is mostly high quality autonomous inspections, where they're using our drones to do autonomous inspections to create 3D digital twins of their infrastructure. Could be bridges, could be buildings, could be electrical power substations, wires, et cetera. And then they use those digital twins and the electrical artifacts to do predictive maintenance, to dispatch human maintainers when required. So again, you and I have always heard about us chasing the brass ring and predictive maintenance for aircraft. Well, that's happening in the civilian world, in the enterprise world, especially in like large capital businesses like electrical maintenance or electrical distribution. So that's kind of our commercial space. Then we have a law enforcement and public safety practice, which has literally exploded in usage over the last year. And that's measured in terms of dollars, sorties, hours, missions, every metric you can imagine. And mostly what we're seeing there is a concept called DFR, or drone as a first responder. And the idea is if you are a law enforcement officer, you're responding to an event, it would probably be good for you to understand, hey, where are the perpetrators? Do they have weapons? Are they in a vehicle? If so, which direction? And then fusing all that information together so that you can create a tailored package to either do one of two things: either collect evidence that you can use later in a prosecution, or to perform some sort of action, whether that's moving in for arrest, etc. So that's our basic law enforcement public safety practice. By the way, that includes disaster response, resilience, awareness. I know several folks were using our drones during the recent Texas floods, which were tragic, by the way. A lot of emergency management agencies have also invested in our drones. They're using those to do pre and post site damage assessment, so they know what they need to bring in only what they need, et cetera. And then our third area is what we call our national security business. And that is focused primarily on defense and intelligence agencies around the world. And there we see, defense organizations are really an enterprise of enterprises. So, defense orgs, they have airplanes, they have infrastructure. So they're starting to dip their toes into using our intelligent flying robots to do something similar to what we're seeing in the commercial space, creating rapid 3D digital twins using an autonomous system to, again, get to that predictive maintenance area. The Navy is doing some interesting work there for topside corrosions. The Air Force is starting to use, they're doing a pilot program right now on some of the heavy aircrafts, including C-5s and C-130s. And then we're also seeing some, security things, much like a city might use drones for that. Drone as a first responder. Every military base is much like a small city, and you've got some of the same security concerns, policing concerns, et cetera. But the bulk of the use cases in the military aspect are what we call a tactical ISR use case. And that is really democratizing air power, down from the echelon level. Whereas in the past, if you were an Army soldier and you wanted a picture of what's on the other side of the hill, you had to probably call the Air Force and get them to task a satellite or send an airplane to the other side of that hill. And now, 72 hours later, you may or may not get a picture of what's on the other side of the hill. Well, the idea here is you can now take a quantum of air power, that ISR air power that you and I know so much about, and put it in the hands of a soldier, or more accurately, in their backpack. And when they need to look over the hill, they take out their intelligent flying robot, they fly it over the hill, and they can see with their own eyes what's there. And now, as we've seen in the Russian-Ukraine conflict, once you see something, many people want to take direct action on it. Or that means, strapping some sort of kinetic activator, a grenade or what have you, on the drone and flying it into a target. We see that sometimes, or using that tactical ISR drone like ours to then spot for artillery, blaze the target for somebody else to affect, what have you. So I kind of think about, that tactical ISR mission almost as it's a mobile JTAC.
Have you seen in the Ukraine conflict that, like, have your drones been utilized over there?
Yeah, they have. So we've actually had drones over there since the very beginning. And I will tell you, we got a bit of a black eye when the first drones went over there because even though we knew they probably wouldn't work, we were kind of encouraged to send them anyway. So in 2022, when the Russians invaded, well, it was the second invasion, obviously 2014 it was one. But in 2022, during that invasion, the Ukrainians started to recognize the value of drones. And there was this huge upswell in the donor community around the world. It was like, send drones to Ukraine. They need them. As a matter of fact, you probably heard this moniker that was created called the Army of Drones. Well, a lot of those donors came to us and were like, okay, stand by. And we had built a drone for the U.S. Army at the time. And remember, this is 2022. So it was based on a competition that happened in like 2018 is when it started. So if you think about knowing how the military buys things, in 2018, that competition was based on requirements that were from 3-4 years earlier. And what was the United States doing in the early 2010s? We were extricating out of Iraq and Afghanistan, where we had spent, multiple, at that time, almost 2 decades. And so during that conflict, we owned the sky. We owned the spectrum. So, there was really no need for frequency agile radio to counter, jamming, because who was jamming? there was no need for a sensor that, could look, 2 miles out, because if you needed to, you could fly right next to someone. There's nothing they were going to do. So we recognized there were some limits on what the drone could do based on what we were seeing in Ukraine. Furthermore, the radio that was built into that first drone was a single band fixed frequency. And it was adding frequency that we're like, this isn't going to work. Just even in that European cell band, it's so close to it, we're like, it's probably going to get jammed just from that. But people are like, nope, doesn't matter. Send it. Everyone, people need it. Lives are at stake. We're like, okay. So we sent several hundred drones. They got sent over. And as predicted, they didn't work well. I will say, however, we could have threw up our hands at that point and said, okay, we're out. We can't do this. And we're like, no, that's not the right thing. And even though no one at the time in the US military was asking for things that could operate in a GPS denied capability, things that could operate electromagnetic, optical, or EW area, no one was really asking for it yet. We're like, this is important, A, for the Ukrainians, and B, it is going to be important for everyone else soon. So our teams, man, we've been over there 36 times in the last couple of years. We actually kept a team over there for an extended period as well. As a matter of fact, we now have some Ukrainian engineers that work for Skydio, and we stayed at it. And so it probably took us 6 months longer than I wanted. But about a year and a half ago, we took our X10D over with a new software load, and we were able to use some of the existing AI capability that we had on the drone to demonstrate that it could operate in a completely GPS jammed environment, a GPS spoofed environment. We put in a new software-defined radio that we were able to create some frequency hopping so that we could avoid RF jamming. And now that has all culminated in our latest software release that we call Asimov, and that's been out now for a while. And all those capabilities are baked in even for US users. So I think, and again, this is one of those things where it's never a destination that you get to and you go, great, we're done. We don't have to do anything else. So we still need to iterate, but we finally have solved some of those problems. And so the short answer is yes, our drones have been used in Ukraine, not very well at the very beginning. Starting about a year and a half ago, though, once we came out with those updates, have been in increasing use as what I call the FAC-A. So you put up a Skydio drone and you can use that to identify, point out targets, because we get some really, really great target derivation capability to get very, very precise coordinates. And now we can translate those over to an FPV drone, and the operator can take that FPV drone, do whatever they need to do.
Are you using, is all your technology in-house, like your AI and your target definition? Are you partnering with some of these other companies?
No, it's all in-house. It's all in-house, but we recognize that, we also have some limits. So I think you will increasingly see more and more partnership. And one of the things we're finalizing right now is an idea of being able to put third-party algorithms on the edge within our NVIDIA chip on the drone, so that you could inference now using your model, because while we have some phenomenal computer vision engineers that have made some amazing models that can identify and track some amazing things, we also recognize that we don't have the data set that, say, you might have for whatever your target sets that you might want. And by the way, I think we all recognize there was a DoD program called Maven, where specifically the DoD was creating some of its own computer vision models to track things that are very specific to the military. So our goal there is to create that platform where you could run that model, again, at the edge on our device as a third-party algorithm. Furthermore, we've made some pretty amazing sensors. The X10, like the FLIR sensor in there, the Boson Plus, is absolutely amazing. The EO capabilities and the zooms are, you're reading license plates from a mile away. It's really, really impressive. We also have a capability now to do all the obstacle avoidance at night with a capability we call Night Sense. So you add all that up and it's great. But again, you as a user might have a capability that is like very limited to your domain, right? And maybe we don't have the expertise to make a sensor that would be valuable. And an example that comes to mind is like oil and gas. So there is a specific sensor that they will use to detect gas leaks. Well, our sensor doesn't do that. And we don't have the capability to make a sensor because we don't have a bunch of gas diffusion experts that do that kind of thing. So what we've decided to do is we've made our platform extensible. And I kind of think about it like I know people used to joke and call the F-16 the Mr. Potato Head of fighter jets because we could put new things on it, new noses, new sensors. Well, in a way, we're making the Mr. Potato Head of drones. So the X-10 has 4 hard points one on top, one on each side, and one on bottom that are merely USB-C accessible. So you can make your OIG sensor, you can plug it into one of those ports, and we have created an easy interface control document so that you can now integrate that into the existing control so that you can control the access to that. And that capability has been used a lot already, specifically by the Army to make a grenade dropper. Because again, we make a phenomenal drone, but Skydio, we are not experts at targeting and making safe arm devices. But you know what the Army is? They can make their own. There are other third parties that are making these. We've had third parties make a dropper to hold a life preserver so that first responders can fly a life preserver out to a drowning victim and drop the life vest. We've had other droppers that people have made to drop med kits. There are spotlights. There are microphones. So if you're a hostage negotiation rescuer, you can fly the drone up to the window and you can speak to them with the speaker, and there's a mic on there so you can hear them. So some pretty amazing capabilities. And these are just the ones that others have thought of so far. You know, I see a future where they're going to be sensors that you and I have never even thought of. They're going to be on some of these small drones.
I'm sure. What's the, I mean, I don't know what you can share, but like price point for one of these drone systems, you know, so I'm local law enforcement or, you know, whatever it happens to be, I want to get like 6 of them.
Yeah. So again, it depends on the software load that you get and the sensors you get. Because again, we've got kind of like 3 levels of sensors. Think about it like buying a Mustang, right? You got the LX version, the middle one, and then you got the GT, right? And based on what you want, you buy that. So roughly speaking, you're probably talking around $5,000 for a drone and the control.
Oh, wow, that's good. So what are some of the, you know, as you've now gotten out to, you know, some of these countries, use cases are expanding. What's the biggest misconception you see with drones, and then more specifically, DoD and policymakers with drones and autonomous systems?
I mean, there are a couple of misconceptions. I mean, just for the lay people out there, I think there's a huge concern that there are just these like random swarms of slaughter bots that are orbiting around, just waiting for a target to appear and then to kill them. That's not happening. As a matter of fact, most of the AI that's baked into these drones right now are doing some very utilitarian tasks, helping the drone navigate. Like, for instance, our GPS denied navigation capability is based on AI. It's based on the computer vision capability of going, okay, I know where I am because I see it. And then over time, my IMU tells me I'm moving, but also I can see the drift of the scene. And based on correlating those two things together, I can keep updating my IMU so I can maintain a stable world frame reference of where I am. And that's how I can navigate without GPS. So that's an example of how AI is being used in navigation capability. You also see AI being used in selecting the radio frequencies for the software-defined radios. Am I being jammed? Yes. Where should I go? There are elements of AI that help make those decisions. So in most areas, the AI capability is actually helping reduce the cognitive load on the operator. And this is no different than when you and I were flying airplanes, right? So when you first started flying the Eagle and I first started flying the Viper, they were steam driven, right? They had no capabilities. We had to do everything. So my little pea brain had to look at the radar warning receiver, the radar, and fuse everything together, and then decide what to do with the stick and throttle and all of the thousands of switches in the airplane to make it do what I wanted to do. But over time, we got new capabilities. Most were software defined where, hey, maybe the radar can auto lock onto something. Maybe there's an altitude hold here. And every time we got a new capability, it took a few of the tasks that our gray matter was having to assess and took care of it. And, as that tank started to get more full of time, we could spend that time doing something more meaningful. And that could be positioning our forces for maximum offensive advantage, what have you. But we got to do that. And you're kind of seeing the same path, although it's happening a lot faster in the drone space, to where we're reducing that cognitive load on the operator so that they're having to do stick and throttle inputs less and less. The drone, if I'm doing stick and throttle inputs to track, an enemy tank, Well, why? When the drone can do that on its own, I can hit the button and go track that. Now the drone can fly itself. Now I can start using my limited gray matter to do more important things, like maybe zoom in and identify, make sure there's not a busload of nuns next to that. So if we need to do an airstrike, get the coordinates correct so I can transmit them to someone else, make the radio call to command, what have you, so that people know what's going on. So that's where the majority of the AI is right now. And this brings up an interesting point because, we're seeing what I call adoption of these automated capabilities. They're happening at different rates. And, I told you earlier, we kind of have those three verticals, kind of commercial enterprise, public safety, law enforcement, and then our national security business. Within the national security space, we're seeing the adoption of those autonomous capabilities happen pretty slow. Now, the rhetoric is there. The rhetoric is all about autonomy and, rapid adoption capabilities, but actual meaningful change, we're not seeing a lot. There is one of those verticals, however, that we are seeing an explosion, and I shared it earlier, in all activities, number of flights, things that it's doing, hours, et cetera. And that's in that law enforcement and public safety community. And so I started looking at that. I'm like, well, clearly they're getting more value out of this than some of our military operators are. Why is that? And as I started to explore it, there were really three things that they were doing differently. The first is they were buying connected drones. So many of the intelligent flying robots that our military customers use, they're completely disconnected from everything. The only thing they talk to is their controller. And, 15 or 10 years ago, when these were first envisioned, that was primarily for a cybersecurity reason. I personally think you can have a secure system that's connected to the internet, but that's a separate subject you and I can discuss later. And by the way, that's in your job jar, so I know that you know that. But anyway, so they're using connected drones, and connected drones open up a host of capabilities. The second thing is they are using docks, which are like little miniature aircraft hangars for a Group 1 SUAS. So it's about the size of a U.S. postal mailbox, the old school blue ones. And they're forward deploying these on rooftops around their cities to create some persistence. And the third thing is they're using a software package that we call DFR Command, but which allows a single operator to supervise essentially an unlimited number of drones. And so they're packaging those things together. And like the primary example is New York City. So right now they're in the process of deploying 600 dock-based drones around the city to strategic locations. And all those docks and drones are now integrated into their broader domain awareness system. And their domain awareness system, so think about that as like a big C2 platform, aggregates signals from all these other sensors to include ShotSpotter, static cameras, license plate readers, all sorts of things like that. And now the Skydio dock and drone become really another node in this broader Internet of Things instantiation that is going on in New York City. So, for example, if a gunshot goes off, ShotSpotter triangulates where that is, now has a coordinate, passes that coordinate through the domain awareness system to our software. Our software goes, drone number 123 can respond to that in 28 seconds, and now sends a notification to the supervisor, notice I didn't say operator, who gets a pop-up on his or her screen that says drone number 123 can respond in 27 seconds. Do you consent? And now the operator clicks consent. The doors open, drone takes off autonomously, drone goes to the scene autonomously, drone tracks suspect autonomously. If there are multiple things there, the drone can now summon other drones to come with it, divvy up where the targets are, and now it can send out a QR code to any responding force. And now any responding force can, on their cell phone, be looking at what those drones are looking at and take control of one if they needed to, which is a pretty impressive capability when you think about it. But really they can do that because of those three things that they're doing differently: connected drone, dock-based to gate persistence, and then the command and control software. And right now, I'm not really seeing that level of commitment within many of the military organizations. It's almost like they are an epoch earlier in their development, where they're still buying drones and they're they're thinking about their interactions with drones on a one-to-one basis, where you've got a single human holding a single controller, doing stick and throttle inputs to the single drone. Now, again, the rhetoric is there for true multi-agent capability and with some of the things, but I haven't seen some of the risk taking that I think you're going to need to do, which is connect your drones, start getting persistence with docks, and doing remote operations through this command and control software.
Yeah, I mean, you would think, especially with what happened in Russia, base defense is important.
Yeah, absolutely.
That tied with then counter drone. What's your thought on that? Because you're big into drones, or the robots.
Yeah.
What is your thought on counter drone tying into the capability you guys have, or just at large?
So I think there are two sides of the counter drone issue. One is technology, and the other is policy. And based on the nature of the drone, the technology is already there in some cases, it's close in others, and needs to catch up in others. What I mean by that is it takes a fundamentally different type of interceptor or capability to knock down or neutralize a Mach 7, hyper speed vehicle, right? Than it does to knock down a, Group 1 2-pound quadcopter. It's just a fundamentally different level of technology. And because really, a small quadcopter, you can knock down with a baseball bat or a 12-gauge shotgun. I mean, the technology isn't like rocket science to knock it down. Now, if you have a swarm of these things, that might be different, but chain link fences, nets, I mean, there are ways to do this, right? I think the major obstacle, especially for small UAS, again, if you get up to the hypersonic vehicles, fundamentally different problem. And I think, we still have probably some technology issues that we need to do before that becomes routine. But on the smaller side, I think our bigger issue is on the policy side. Because again, if the technology to knock something down is there, it's a known issue, you know how to do it, but you don't do it, well, why don't you do it? Well, could be money, but again, these are low-tech things, so probably isn't a money issue. I keep going back to this policy thing, and I go back to what we saw, I think it was a year and a half ago, 2 years ago, all these small drones were flying over Langley, right? And everyone was hemming and hawing and clutching their pearls, like, oh my goodness, how do we solve this? Well, you could have solved it with a shotgun, but no one felt empowered to shoot something down with a shotgun, whether it was due to, the FAA does on the airspace. Well, if it falls on someone and hits them, they're going to sue. So there are all these reasons. But at the end of the day, all the pearl clutching was over, in my mind, mostly policy issues, because if someone said, take it down, I'm convinced those things can be taken down pretty darn quickly. So I think the policy side is going to be important. So Congress is going to have a role there. There's going to be the back and forth between DoD, DHS, FAA. And this is all good, but at a certain point, someone's going to have to give some clear guidance on when you can take risk, when you can't. And obviously, the context of are we in a war or not will be an important part of that.
Yeah, couldn't agree more. Is confirmed, I'm pretty sure it's true, but Skydio is all made in the USA.
Correct. Yep.
Tell me.
So we were recently sanctioned by the Chinese government. I don't know if you saw that.
I did not know that. Congratulations.
Yeah, thanks. That was actually happened about a year and a half ago. So about 4 or 5 years ago, Skydio recognized that because we did have Chinese parts, we're like, you know what? We can see where the ball is going here. We need to decouple from all our Chinese supplies. So we started doing that about 4 or 5 years ago. And we started with the smart parts, the chips and the things like the sensors, et cetera. And we were completely weaned off of those. And so about 2 years ago, we were working with the Taiwan National Fire Department. We wanted to use some of our drones in a disaster response role. And the Chinese used that as a pretext to sanction Skydio, and specifically the companies that were providing Skydio supplies. And at that time, we had decoupled out of China for everything except the battery that we were still getting from China. So that took a while, because not only batteries have certain rare earths that are hard to get, but also for one that you want to put on a small intelligent flying robot or drone, it's got to be packed just right, need a lot of energy density because you don't have a lot of room for spare weight. We are completely off the old supplier. We have now multiple suppliers that are outside of China, and we've got some resilience built into that. So we're pretty excited about it. But yeah, American made.
That's great, obviously, and good on you for recognizing supply chain security. I mean, that's important.
Yeah, it's a big deal.
Great. So, what excites you most about the evolution of autonomous systems, your robots over the next 3-5 years, and kind of a national security construct?
I kind of gets back to what I said earlier, right? Like, I'm seeing almost the future of where I think the military forces can go in current day law enforcement, right? So just watching the way they're using it. Again, I don't know if cost pressure drove them there. I don't know if risk tolerance drove them there. I'm not really sure what drove them there. But when I see what's going on there and I kind of transpose it to what I think we can see in the military, it is super exciting. So first off, I think right now, most military use cases you've seen, you've got, ground forces on the battlefield, hand flying a drone. That's what you see. I think increasingly you're going to see more and more, small UAS systems being used in like that more broad set of use cases from base security to aircraft maintenance to ship maintenance to scouting out landing locations for combat control teams to being a critical node in the TACP system. We're calling it airstrikes, and increasingly it'll be used like that. I think you're still going to see more and more use in the tactical ISR space, but I think instead of having hundreds of soldiers each hold one controller and fly one robot, I think you're going to see something that looks more like dock-based remote operations, where you're going to have ground vehicles, maybe air vehicles. They're going to have little pods on them, and in those pods, there are going to be intelligent flying robots that, when they eat you, are going to get kicked off the side, kind of like those little sucker fish on a shark, and they're just going to go off and do their thing, find a target, report back to someone, and have a single operator, maybe in the TOC, maybe in the lead vehicle, that they can then consent to whatever the follow-on action is. And I think that is well within the technical capability of happening today. It's going to take a little bit of risk tolerance and a little bit of vision. But I think we're starting to see like the hard candy shell break off of some of this, risk averseness that we've seen, and get to the warm candy center.
Awesome. So I've had on podcast / customers. So, Vanton is a submersible underwater robot, Havoc AI, surface, growing, similar kind of concept, but in different domains.
Well, and I think what you're going to see is a fusion of these things working together.
That's what I was going to ask. Is that something you guys are thinking about to use your platform to fuse, or is this someone else that's going to be able to bring these? So now that one operator can put in a mission objective,
right,
and it will deploy, okay, these 3 boats, this underwater thing, these 3 sitting in a mailbox on some island take off, and they go solve a mission.
That's right. So the short answer is our platform can do that. I think at the end of the day, when I say that, can fuse together the multiple domains and issue commands. And there's some basic robotic languages, RAS-A and some others, or RAS, and then there's RAS-G for ground, A for air, et cetera. So, there's some basic frameworks out there that help make this a reality. So we're going to see that. But, I think there are inherent limitations in all small things, right? So for instance, some of the small UAS that we're talking about, are intelligent flying robots. You know what? They fly roughly 45-ish minutes, right? The current battery level and motors. Now we have some things in the drawing room that we're not ready to release yet, but can solve some of these problems. But that creates a range problem, right? And so you and I used to think about things in terms of combat radius. And we're like, okay, we're here, we got to get there, do the job, then get back. How many times do we have to refuel? That's how we mitigated it. Where with a small UAS, you might not be able to do that. But what if I didn't have to fly the small UAS all the way there? And this is where I think now, as military planners have seen what happened with Operation Spiderweb in Ukraine and Russia, now people are starting to go, oh, I see the bigger picture. What if I could put 1,000 small UAS on a boat that doesn't have a human on it, right? And that thing floats up next to where it needs to be. And then all these little hockey pucks that are drones come off and they'll do their job. That's a way, using tactics, you can mitigate an inherent, physical limitation of a thing. And I think you will see more and more of that. And that's why I think this idea of connected things is of increasing importance to DoD, and why they need to get away from this idea of, I want it all disconnected. Because if it's all disconnected, you will forever be limited by the physical limitations of the thing you have in your back pocket.
Oh yeah. I'm just thinking unmanned boat or service vehicle hits the ground, a bunch of, unmanned ground vehicles scatter,
Right.
drop off their docking stations, come back, leave, and now those things are ready to go at a moment's notice. So yeah, super cool.
Yeah, no, it's amazing, and again, it highlights, that this is why, people are like, hey, are we replacing humans? Well, you might be getting the human, out of the dangerous spot, but we're not replacing humans, because it's only someone like you with the background, or an actual warfighter that can think through that and go, ooh, yeah, this drone only goes 45, minutes, which, might translate to 20 kilometers, but I can get it closer by doing this. I guarantee you, there are going to be thousands of, kick-ass tech sergeants and smart master sergeants and sergeants majors. They're going to come up with shit you and I have never even thought about.
Oh yeah.
And that's where I think human ingenuity is still going to be valuable. And why, if we can take all the cognitive workload of manually flying these things and operating these things off people, then they can start using that cognition to solve what the real hard problems are, which is the one you and I just talked about.
Absolutely. So cool, Drifter. Well, thank you for your time and join us. Unfortunately, time's to go, but I know we'll get a chance to talk more. But what you've done, your journey, and then Skydio, what a great episode. So thanks so much for sharing.
Yeah, you got it, man. Enjoyed it. Take care, man. We'll see you around.